Hi everyone. So let's start from this section from our module rational expression. So we started talking about solving rational equation in our last class, and we actually started the first example, but we'll start again from the first example. Okay. So we are trying to solve this rational equation. Notice that this is a rational equation. We have an equal sign in between, right? So what we'll do, there's a question, as you can see, are there any values that must be excluded? Right? We'll talk about that later. But let's try to solve this equation first. Means that you're trying to find some solution of the variable u. Now, for that, since it's a rational equation, it's not just any linear equation that we can just combine the like terms, isolate the like terms in one side, constant in the other side, and solve, right? So what we can do, we can try to make it a simple linear equation or a simple equation by clearing up all the denominators, clearing up all the fractions. How can we do that? For that, we need to find the LCD first. Now, in terms of LCD, all of our expressions here has to be in factorized form, as you know. So let's try to check if everything is in factorized form or not. The first denominator, 8u minus 8, right? So since this is a linear, the only thing we'll check is the greatest common factor. Do you have any greatest common factor here? Yes, 4. So let's factor out the 4, and what is left? U minus 2. The other term is negative 1 equal 2 divided by u minus 2. Now looking at all of our denominators, the first one, 4 times u minus 2. The second one, nothing, so it's just 1, right? So the second denominator is just 1, and then the other side is just u minus 2. So what is our LCD? That means if we try to make all the denominators look similar, what is that denominator that will try to make them, right? That will be the common factors for all of them, which is u minus 2, and then we'll see in each of them what is missing that you want to match them, you want to get from the other. That is, we can see a 4 on the first denominator, right? And there is nothing else extra in other denominators. So the LCD on this problem is 4 times u minus 2. Okay, now once you know the LCD, what we are going to do? We are going to multiply each of the terms by the LCD. Why? Because we want to clear up the fraction or the denominators. Okay, so let's go ahead and do that. So we are multiplying each of the terms by the LCD. I'll use to write, I'm using another color while I'm multiplying by the LCD just so that it makes sense more. And notice that we are multiplying by the LCD means it's in the numerator and the denominator is just 1 for this, right? And then we have negative 1 times multiplying that by the LCD. We need to multiply all of our terms by that, right? The other side, 2 divided by u minus 2, multiplying by that the LCD. All right, now let's see what happens. Uh, Again, our goal was to clearing up the denominators. Let's see if we can successfully clear up the denominators or not, right? So what happens here? The 4 times u minus 2 and the 4 times u minus 2 get cancelled. Here, there is actually no denominators in the second term, so no cancellation. On the other side, u minus 2 get cancelled. What is left after all this cancellation? On the first term, we are left with 8, nothing else. The denominator is just 1, so we can just not write it. Here, in this next term, we have 1 times 4, which is just 4. And then if you distribute the 4 with a negative, of course, then it will become negative 4u and negative, negative, positive 8. On the other side, what we left is a 2 and a 8, 4. So 2 times 4 is 8. So what just happened? We actually cleared up all the denominators. No fraction anymore, right? So now we'll just combine the like terms, okay? So in terms of combining the like terms and isolate the variable in one side, the constant in other side, first of all, I can see 8 and 8 here. So I'll have 16 minus 4u equal 8. And so now let's subtract the 16 from both sides. So we are going to have negative 4u equal negative 8. What's next? Let's divide both sides by negative 4. And so we finally get u equal to what? Positive 2 is our solution, right? Okay. All right. Now let's go ahead and try to check any restriction. All right. So what does it mean by checking the restriction? So notice that since you are dealing with rationals, there's always the chance to be undefined, right? Now, from our original problem, we'll check all our denominators, okay? Our original denominators, 4u minus 8 in factorized form, which is 4 times u minus 2. The other one is u minus 2, right? So from the original denominators, but if we set each of the factor u minus 2 equals 0, what do we get? We get u equal to 2 is a solution. U equal to 2 is a value for which the denominator will become 0, right? That means in this equation, u can be anything except 0, right? And notice that the solution we got, the solution we just calculated out of this equation is u equal to 2. The value that will make the equation undefined, each of the rational undefined, right? So that means we cannot keep this solution because that's not just a valid solution. It will make everything undefined, right? So in this kind of case, when the solution you got out of the rational equation is making all the denominators 0, then what is our final answer? No solution. Okay, so u minus, even though we have solved u equal to negative u equal to 2, this is not a valid solution. So in test, what do? You do all the works, you find your solution, you check your denominators for the possible value that will make the denominator 0. If that match with your solution, then the answer is no solution. If that doesn't match, then you keep your answer, and that's a valid solution. Okay. All right, let's move forward with our next example. So moving forward with our next example, we'll just do the same work. We are looking for the solution of y. So we need to find the LCD first and multiply each of the terms by the LCD. So once again, to find LCD, everything has to be in factorized form. So here in this denominator, the greatest common factor is 3. So let's factorize 3. We are left 3 y minus 6. Subtract 2. So what is the LCD? The common, looking at all the denominators, y minus 6 is the common factor. What else? To adjust 3. So this is our LCD. Let's multiply each of the terms by the LCD. 3 times y minus 6, that means the denominator is just 1, equal 3 times y minus 6. So what I'm doing is multiplying all of my terms by the LCD. So it's 3. All right, so what happens then if I multiply by the LCD? Again, our goal is to clear up the fraction, and let's say that if that works or not, okay? Notice that that should work. If that doesn't work, that means we are doing something wrong, okay? So the y minus 6 get cancelled. Here, 3 times y minus 6, 3 times y minus 6 get cancelled. What is left? Negative 6 times 3, which is negative 18, equal. On the first term, nothing left, so it's just 1. And then here, 2 times 3 is 6, and then we'll distribute the 6 with the terms inside. So it'll be negative 6y and negative positive 6 times 6, which is 36. All right. So now let's combine the like terms. So we have negative 18 equal 36 plus 1, which is 37. Subtract 6y. Let's subtract 37 from both sides. And we are going to get what is 18 minus 37. So 18 minus 37 is 19, negative. Negative 55 equal negative 6y, right? So let's divide both sides by negative 6. And we get y equal negative will be positive 55 over 6. Okay. Now we need to check for restriction, right? So that's our solution that we calculate, but we need to check for the restrictions. And according to the restriction, from our original denominators, we get the factor y minus 6. And from the y minus 6 equals 0, we get y equal to 6 is the value that will make all the denominator equal to 0. Not all, but at least some of them equal to 0. So if our solution is not 6, but anything else, then that's valid, right? So our solution indeed not 6. So this is indeed a valid solution, and that's our answer. So if you get an invalid solution, your answer will be no solution. Okay? All right, let's move forward. So for the next problem, next equation, we have one more equation to solve. The next equation, again, we are doing the same work, okay? We have three rationals in both sides of the equation. So we are trying to solve here for y, so we need to find our LCD first. Okay, now let's make all the denominators in factorized form. On the other side, my denominators is a quadratic. Y squared plus 10y plus 16. Quadratic with 3 terms. And the constant term is 16. The leading coefficient is 1. So I need factors of 16 that will add to the middle coefficient 10. Right? So what they can be? 8 and 2. Does this work? So 8 times 2 is 16. And if you add them, it's 10. So yeah, that works. So y plus 8, y plus 2. Perfect. Now let's look for LCD. On my first denominator, I have y plus 2, the factor. To match with the second, I have y plus 8, the factor. Next factor. And the third is actually the product of y plus 2 and y plus 8. So that's our LCD. Y plus 2 times y plus 8. All right? Let's multiply each of the term by the LCD to clear up the fractions. So the LCD y plus 8 times y plus 2, the denominator is just 1, plus 4 divided by y plus 8 times the LCD. The other side, y minus 16 divided by y plus 8 times y plus 2, and multiplying that by the LCD. I need space, so I'll just try to narrow down. Okay, perfect. So multiplying that by the LCD, y plus 8 times y plus 2. Okay, divided by 1. All right, perfect. Now what happens? Do we clear up the fractions successfully? The y plus 2 get cancelled on the first term. Second term, y plus 8 get cancelled. On the other side, y plus 8, y plus 8, y plus 2, y plus 2 both get cancelled. Okay, now let's write what is left after all this cancellation. On the first term, what will left? Y times y plus 8. On the second term, what will left? 4 times y plus 2. On the other side, we are left with y plus 6. That's it. All right. Now let's get rid of all the parentheses and do this distribution. So the first term, if we distribute the y, it becomes y squared plus 8y. On the second term, let's distribute the 4. So 4y plus 8. On the other side, it's y plus 6. So notice that it's turning out to be a quadratic, right? So let's move everything on left side. So let's subtract y and subtract 6 from both sides. So what we'll get after that is y squared, and 8y plus 4y is 12y, and subtract another y is 11y. And 8y subtract 6 is positive 2. That's equal 0. All right, let me double check if I'm correct. Okay, I think I made a mistake, but it's not major mistake, so I can just fix it. Originally in my equation, I had 16, but somehow here I made it a 6. So I'll just correct that. Here it was subtract 16, which mistakenly I have keep writing as plus 6. So let's just correct all of them, okay? And equation here. So it was negative 16, negative 16. So we need to add 16 on both sides. And so our quadratic is y squared plus 11y, and 8 plus 16 is positive 24 equals 0. All right, now this is a quadratic. And since we are solving it, we'll solve this, we will factorize this, and we'll get two solutions for y, right? Now, in terms of factorization, this is a quadratic with three terms. The leading coefficient is 1. So we'll find factors of the constant term. The find factors of 24 that will add to middle coefficient 11. So what could be some factors? So factors of 24, I can think of 8 and 3. And so if we add them, we get 11. Perfect. So the factors will be y plus 8 and y plus 3. So 8 and 3, if we multiply them, that's 24. If we add them, we get 11. So now let's set each of the factors equal 0. And we get the first solution, y equal negative 8. And the second solution, y equal negative 3. All right, now these two are solutions, but again, don't forget to check your denominators, right? Now, from our original rational, all of our denominators are y plus 2, y plus 8. And from the other, we got the same, y plus 2, y plus 8, right? That means for the restriction from the original equation, we get y plus 2 equals 0. That means y equal negative 2 is a value that will make denominator 0, and y equal negative 8 is the other value that will make denominator 0. Actually, let me go back and show you. So other denominator is y plus 8. That means y equal negative 8 is another value that will make our denominator equal 0, right? So we cannot have this solution. If we have any of these solutions, they will be invalid. So let's check our solutions. Yes, indeed, we have the solution y equal to negative 8. So this is not a valid solution. All right, so only valid solution is this one. So our answer is y equal to negative 3. So we are dropping the y equal negative 8 here. We are dropping this because that's not a valid solution. All right? I hope it makes sense. Now we are done with our module for rational expressions. All right? So now for the rest of the class, I'll move forward and I'll try to work with our study guide, okay? So let me move forward and open the study guide. So this is our study guide. Let's quickly try to look at each of the questions here, okay? So I'll actually try to be quick here. So the first question is use the graph of the parabola to fill up the table. All right. So in this parabola, the first question, does the parabola open upward or downward? Of course, as you can see, it's open downward. Find the x-intercept, so where the graph is crossing the x-axis. So first of all, the first x-intercept is going to be negative 6, 0. The other one, as we can see, 2, 0. The y-intercept crossing the y-axis at 0, 3. Find the coordinates of the vertex. So let's find where the vertex is here, right? How do you know it's the vertex? Because in two sides of the vertex, it's symmetric, right? That means you have the axis of symmetry at the vertex. And it's symmetric in that. It's get divided in two symmetric parts in that. And the vertex will be negative 2, 4. Find the equation of the axis of symmetry. So of course, as we know from the vertex, x equal to the x coordinate is our vertex. axis of symmetry all the time, right? So axis of symmetry is x equal -2. This vertical line, right? Okay, let's move forward to the next. Graph the parabola. Okay, so in order to graph the parabola, what do you need? The first thing we need is the vertex. So this equation of the equation of the parabola, the function of the parabola is in standard form. That means it's in the form of ax squared plus bx plus c. So for this, the formula for the vertex was -b/2a for the x coordinate, and for the y coordinate, the corresponding functional value. So for the x coordinate, we'll find what is our -b/2a. From our equation, our a is 1, b is -8, and c is 20. So negative of -8, because my b is -8, and this negative is coming from the formula. And 2 times a is 1, so we get +8, negative, +8 divided by 2, which is 4. That's our x coordinate. For the y coordinate, we need to find what is the value, what is the functional value for x equal 4. So f of 4 is our y coordinate. So 4 square subtract 8 times 4 plus 20. All right, so now let's calculate that. And if you calculate that correctly, go ahead and do that by yourself. It should be 16 subtract 32 and plus 20. So 16 plus 20 is going to be 36. Subtract 32, which is 4. Our vertex is 4, 4. Let's look at that. So 4, and then top here 4. Okay. Now, what is our axis of symmetry again? Axis of symmetry is going to be the line x equal the x coordinate of the vertex, which is 4. So that means the vertical line passing through this. Okay. Now, in order to graph the parabola, what else do we need? We need at least 4 points, and there has to be two from left of the axis of symmetry, 2 from right of the axis of symmetry. Right? So let's find 4 points. What does it mean by finding 4 points? Coordinates, right? So we'll find 4 order pairs, at least 4 order pairs, considering both sides of the axis of symmetry. So from the left of the axis of symmetry, which is the axis of symmetry is x equal 4, from left, what point we can choose? Let's choose 2 and 3. And from right, we can choose 5 and 6. So now what we need to do, we need to substitute these values into our function y here and find the corresponding y value. So if we substitute x equal to 2, if you calculate them by substituting here, do the algebra by yourself, okay? And check with my answer. I calculated y value is equal 8 if I substitute 2. If I substitute 3, I get 5. If I substitute 5, I get 5. If I substitute 6, I get 8. So these are my 4 order pairs. Now let's go ahead and plot them. That was by vertex. Let's make it a little bit bigger. And now the other points, 2, 8, 3, 5, 5, 5, 6, 8. So by the graph that's passing through these points will be this, right? Upward parabola. And also you can check if it's an openward or opening upward or downward parabola by what? By the leading coefficient. In this, what is our leading coefficient? A. A is 1. right? So if the leading coefficient is positive, it opens upward. And if somehow in some question you get the leading coefficient is negative, then that means it's open downward. All right, so let's move forward. Now this is just the same question. I'll just help you a little bit with that. So on this, this is what kind of form in this the equation of the parabola here. This is in the form of vertex, right? So the vertex form of the parabola was y equal a times x minus h squared plus k. And the vertex from the vertex form is hk. So in the formula we have a negative h, right? Yeah. So and the h is our vertex, the x-coordinate of the vertex. Now this is actually the vertex form. So that means by following the vertex form, what is our coefficients? Our a is what? -1, because look, we have a negative, right? What is our h? Is it +2? No, because we need a negative in between the x and the 2 for the formula. So if we need the negative, which is already positive here, what does it mean? That means our h is -2. And what is k? K is +3. So notice that we already have our vertex. Our vertex is hk, which is -2, 3. All right. What is our axis of symmetry? It's the line, vertical line, x equal -2, the x-coordinate. Now, what else we need? You can quickly check the opening upward and downward thing. So a here is -1, which is negative, so it's going to open downward. All right, so the next thing we need to plot it is points from left and right of the axis of symmetry. Okay, so the vertex is at -2, +3, which is up here. And the axis of symmetry is the vertical line x equal -2. So we need 2 points from the left, 2 points from the right. All right, so let's pick 2 points from the left. We can pick -3, -4, and to the right we can pick -1, 0. All right, so now we need to go ahead and plug them in and find let's do the algebra and find this point. Okay, so if we plug in -3 in our equation here, so we are going to get -3 plus 2 squared plus 3, which will be negative of -1 squared plus 3, and -1 squared is just +1, right? So, and then on the outside you have a -1 plus 3, which is +2. For -4 plus 2 squared plus 3, negative, here we'll have -2 squared plus 3, and so negative times -4 plus 3, which is -1. Right. For -1, it's 1 squared plus 3, so 1 plus 3, -1 plus 3, which is +2. For 0, we get -4 plus 3, which is -1. Perfect. These are our order pairs. Let's try to locate them. So -3, 2, -4, -1, -1, 2, and 0, negative, actually -1, but I am at -2 here, so -1 and 0, -1. Okay, perfect. Now the graph is going to pass through all these points and opening downward. Perfect. Right? Let's move forward. The next question, find all the x-intercept and the coordinates of the vertex of the parabola. All right. So for this one, for the x-intercept, what do? We set the y equals 0, right? Now, the first thing, let's find the vertex first, okay? This is in the standard form, so the vertex will be negative b over 2a and f of negative b over 2a. Okay, find the vertex. Here, a is 1, b is 14. So our x coordinate is going to be negative 14 divided by 2, which is negative 7. And our y coordinate will be the corresponding y value if we substitute negative 7 in the equation, right? So if we substitute negative 7, we'll get (49) subtract 14 times negative 7 is 98 plus 49, and actually 49, if we add them, we get 98, so everything cancels. So our y coordinate is just 0, so our vertex is negative 7, 0. All right, now to find the x-intercept, what do? We set the y equals 0, so we will get this quadratic. Right, now out of this quadratic, what you need to do, you are solving this quadratic by finding factors of negative 49 that will add to 14. Can you think of any factors like that? 7 and 7. So negative 7 and let me see. Oh, actually everything was positive. My bad. So this is positive 49. Yeah, now 7 and 7 works perfect. So x plus 7, x plus 7. So if you multiply 7 and 7, 49. If you add them, it's 14. So that means our solution are x equal to 7 with multiplicity 2, right? Because it's the same factors twice. All right. That's it. The next question, answer the questions for this quadratic. Does the function has minimum, maximum, or what, right? So the first question, does it have minimum or maximum? How do you know that? You need to check the leading coefficient only. That's it. What is the leading coefficient? That's negative 3, which is negative means it's open what? Downward. If it's open downward, what do you have at the vertex? Max or min? A max, right? All right, perfect. Now, what is the function's max or min value? First of all, we're having max. And what is the max value? Is going to be the y coordinate of the vertex. And please know that max or min, whatever is happening, that's going to happen in the vertex, right? So the first thing you need to find is the vertex of the parabola. Okay, use the formula negative b over 2a over f of negative b over 2a. Do the algebra by yourself. So here a is negative 3, b is 24. Find the x coordinate and find the y coordinate for the corresponding x value that we find. Okay, so now if we find the x coordinate for a being negative 3 and b 24, we are going to find that negative 24 divided by 2 times negative 3, so we get negative 24 divided by negative 6. So negative will be positive, and then 4, right? So, and then if you substitute 4 in the function for the y coordinate, we'll find the vertex is 4, -3. So that means what is our maximum value? Y equal -3. Where does the max or minimum occur? What does it mean? It means at the x coordinate of your vertex, okay? X equal 4. At x equal 4, the max or min occur. In that case, the max occur. All right. Okay, the next question. It says we are trying to find the unit cost of a manufacturer copy machines company. So C represent the unit cost. Depends on the number of machine made. X is the number of machine made. All right, and C is the cost. So we are trying to find how many machines must be made. So how many machines must be made to minimize the unit cost, so that C is minimized. Okay, so there can be two questions, like how many machines made to minimize the unit cost, and then what is that cost. All right, so again, notice that the cost function we are given is a parabola. That means the minimum or maximum, whatever is happening for this cost function, that is going to happen on the vertex. All right. So notice that the leading coefficient is 0.3, which is positive. That means it's a opening upward parabola. And of course, for opening upward parabola, we are going to have a minimum at the vertex. So here, to find what is the number of machine for the minimized cost, we just need to find the x coordinate of the vertex. So the vertex formula here for the standard form is -b over 2a, f of, in that case, c of -b of 2 over 2a. And our first question, number of machines, is the x coordinate of the vertex. So c b x equal -b over 2a. And here b is -78. Divided by 2 times a is 0.3. Let's go ahead and use your calculator to solve it. So 78 divided by is I got 130, the number of machines. Go ahead and check by yourself, right? And the second question, what is the minimum cost? That means we need the y coordinate. That means we'll substitute x equal 130 in the function, okay? So we'll get c of 130 square, subtract 78 times 130 plus 12092. Go ahead and just do this addition, like whatever algebra is needed, okay? And that will be our minimum cost. Perfect. Next question, find the equation of the quadratic equation function for the graph shown below. So notice that our vertex is -5, 2. Our other point is -7, 6. What do? We use the vertex form of the parabola, right? And so our vertex is x minus h is -5 plus k is 2. So if we get a times x plus 5 squared plus 2. Now for the equation, what else we need to do? We still need to find what is our a, right? For that, we will use the other point that we are given. So we'll satisfy our equation by the point -7, 6. That means the y value is 6 equal the x value is -7. So get 6 equal a times -2 square plus 2. So 6 equal -2 squared is +4. So 4a plus 2. Let's subtract 2 from both sides. So we'll get 4 equal 4a, divide both sides by 4, we get a equal 1. So our final equation is y equal a is 1. So x plus 5 squared plus 2. That's it. All right, next question is graphing the inequality. All right, so from each of the is in the factorized form, right? So we don't have to find the factors by ourselves. So from each of the factor, by setting them equal to 0, we'll find the point where we'll divide the number line. So the first point we'll divide the number line is x equal -4. From the other factor, the other point we'll divide the number line is x equal +3. So at -4 with a open circle, because it's strictly greater than, and at 3. All right, so we are dividing the whole number line in 3 parts. The first part is negative infinity. That means a different color. Negative infinity to -4, -4 to 3, and then 3 to infinity. What do we do next? We pick some test values for each of these subintervals and check which one satisfy our inequality, right? So let's go ahead and do that. I don't have enough space. I'll just use this space here. So our subintervals are negative infinity, -4, -4, 3, 3, infinity. And so test value, and what do we get for the functional value? All right, that means, which is x plus 4. We'll substitute them in x plus 4 times x minus 3. All right, so the first test value in this interval we can pick as x equal -5. For the second, we can pick x equal, let's say, 0. For the third, we can pick x equal 4. If we substitute x equal -5 here, so -5 plus 4 is -1, -5, -3 is -8, and so -1 times -8 is +8. So the main point is we get positive for the first subinterval. The second subinterval, if we substitute 0, so 0 plus 4, +4, 0 subtract 3 is -3, and +4 times -3 is -12. So negative for the second subinterval, positive for the first. Finally, for x equal 4, 4 plus 4 is 8, and 4 minus 3 is +1. So for 8 times 1, +1 is +8. So positive for the last. All right, now let's check our inequality. According to our inequality, it has to be strictly greater than 0. What does it mean? That means it has to be positive to be strictly greater than 0. And so we are positive on the first subinterval and the last subinterval, correct? Here and here. Okay, so our solution is -infinity to -4 with open parentheses because open circle, union 3 to infinity. So how do you plot that in the graph? Our graph is open circle 3 to this left side and -4 to infinity. Okay, that's it. All right, the next question, it's another inequality, but it's not in factorized form. So you need to find the factors first. I'll help you up to the factorized form, and then you need to follow the question 8 that I have just presented by yourself. Finding the subintervals, picking test value for each of the subintervals and testing them, and then finally decide what is your solution by yourself. Okay, so if you find the quad factors, so first thing we'll do is subtract 6x from both sides. So you'll get x squared minus 6x greater or equal to 0. Excuse me. And then to find the factors, what can we do? Quadratic with two terms, so check for greatest common factor. There is a greatest common factor, x. If you factor that, what is left? X minus 6. Okay, now from each of the factors, if you've said the first factor equals 0, so x equals 0 is first point where it will divide the number line. The other point is x equals 6. That means take the number line and divide the number line at, let's say we have 0 here and -1, -2, so on. 1, 2, 3, 4, 5, 6, and so on. So 1, 2, 3, 4, 5, 6, 7. All right, so that means now we are going to divide our number line at 0 and 6. It's greater or equal, so they are going to be closed circle. Okay, so our divided number subintervals are -infinity to 0, 0 to 6, and 6 to infinity. All right, and now build this table. And pick some test value, substitute them at x times x minus 6 to check which one satisfy our inequality. And that's, please try by yourself. If you do it correctly, the correct solution is going to be, you need to do this by yourself, okay? The correct solution is at the back, at the very end of this PDF, all right? The next question, checking them, which one is a polynomial, which one is not. All right, pretty straightforward. The first one, h of x equal -2. It's a constant, but still, is it a polynomial or not? Yes, it is. Because even though it's just a constant, what does it mean? That means we don't have any variable, right? So it's a constant polynomial. But if in case you were wondering, what does it mean? It means that, as you know, how anything power 0 is 1. So we don't have any variable. It just simply means that we have the variable with power 0. That's why it's just 1 and we don't see it. All right. So yes, indeed, it's a polynomial. The second one, all the exponents. Let's check all the exponents. As we know, to be a polynomial, our exponents have to be non-negative integer. So let me write it somewhere. All the exponents have to be non-negative integers. And 9 and 4 are non-negative integers, so yes, polynomial. The next one, as you can see, is a fraction, right? What does it mean? It means that it's in power form is x power -7, right? So checking the exponent, it's not a non-negative integer, so it's not a polynomial. The last one, the first one, in the last function, the first exponent is 2, non-negative integer. The second exponent is 1, non-negative integer. For the third one, x square root of x in power form is x power 1/2, right? It's not a non-negative integer. Okay, it's not an integer. That means it's not an polynomial, right? The next question, find all the zeros with their multiplicity. Since the polynomial is in factorized form, finding the zeros is straightforward. So we can build this table. For the first factor, x plus 2, if you set that equal to 0, we get x equal -2. So the first 0 is -2, 0. What is the multiplicity? Is 1, because the exponent on the top of this factor is 1. So the second, oh, my bad. The second factor is x plus 8 equals 0. So we get x equals -8. So the 0 is -8, 0, multiplicity 1. The last one, x subtract 11 equals 0, we get x equal 11. So 11, 0, multiplicity 3. Question, what is the degree of this polynomial? We add all these exponents of all the factors, right? So the degree of the polynomial is 1 plus 1 plus 3, which is 3 plus 1, 4, 5. Okay, leading coefficient. What is the leading coefficient? N. So 4 times each of the coefficient with all the x in each of the factors. 4 times 1 times 1 times 1, so just, sorry, 1. So the leading coefficient is just 4, right? Perfect. Now, another quick observation, even though I don't have it, but I'll do it anyway. Cross or touch. So how do you know cross or touch? If it's an odd multiplicity, there's a cross point. If it's an even multiplicity, touch point, right? So odd multiplicity cross, even multiplicity touch. So the first one is a cross, second one is a cross, third one is a cross. All of them are cross, no touch point. Perfect. All right. For the next one, find the x and y intercept. Is pretty straightforward. For x-intercept, set y equals 0. So, and for y-intercept, you need to set x equals 0, right? So if you set x equals 0, you will get y equal 2 times 0 plus 12 times 0 plus 16 times 0. So actually, the y-intercept is just 0, right? Y equals 0. For x-intercept, if you set y equals 0, then you need to solve this, right? So the first thing you need to do is factorize the common factor, is x, actually 2x. What is left is x squared plus 6x plus 8, right? Then if you factorize this quadratic, what do you get? I'm kind of out of space. So 2x times the common factor of 8, that will add to 6. 4 and 2. Yeah, that works. So x plus 4 and x plus 2. So our x-intercepts will be the first factor, setting each of the factor equals 0, right? The first factor is 2x. If you set that equals 0, we get x equals 0. For the second factor, x plus 4, if you set that equals 0, we'll get x equal -4. The second last factor, if you set x plus 2 equals 0, so we'll get x equal -2. So x-intercepts are 0, 0, -4, 0, and -2, 0. Okay, and the y-intercept was just 0, 0. All right, I hope it makes sense. Okay, so I'll stop here. Our class time is actually over. I'll upload this PDF on D12. I'll try to quickly write down the other solutions a little bit in a short form. I will not go very detailed, but you need to practice them by yourself, right? Let me know if you have any questions, and thank you so much for your help. I'll see you all on Monday, and very, very good luck for your test 3. Okay, please let me know for any questions. Thank you so much.